Hello, Stallions. Welcome to another day of class. It is Thursday. It will be Thursday, August 20th, 2020. 2020. Look at that. Ha ha. Now, what is scientific inquiry? That is what we're going to go over today. So today we're going to go over the scientific method. Yesterday, we did a real brief introduction into our sciences. If you were in earth science, we talked a little bit about earth science. If you were in biology, we talked a little bit about biology. Today, we're going to talk today we're going to talk about the scientific method and scientific inquiry. I'm going to move my face up here real quick because there's going to be some writing that's going to pop down on later slides. So, let's talk about it. What is scientific inquiry? It is a process of investigation that leads to producing more knowledge based on making careful observations and creating explanations that make sense of the observations. Okay, so a key part of scientific inquiry is going to be our ability to make observations. Now, we have two different kinds of observations. We have qualitative observations and we have quantitative observations. Quantitative observations have numbers. They are they're measurements basically. So we can measure how fast a plant grows. That is a quantitative observation. Then we have qualitative observations, which are qualities such as colors, properties, things like that. Now, everyone performs the scientific process every single day. It is our problem-solving process. In fact, we have started e-learning this week. This is a huge chance for this scientific process to come about because we are solving a problem. Our problem right now is that this e-learning may not be working the way that your teachers had anticipated. I know it's not working the way I anticipated it for me. I know that for a fact. So I've had to troubleshoot things such as links. For example, the video notes that we did yesterday. Had to troubleshoot that. I had to fix that during the day because what I did with it didn't work. So I had to make an observation of, okay, this is not working. If I change this, then this will happen because of this. That's a hypothesis statement. We all do this every single day. You guys do it when you're troubleshooting. Why did my phone die, but it was at 50%? Why isn't my car working? Why doesn't this link work on this assignment that Mr. Disney wants me to do, but it doesn't work? Why? That is all scientific inquiry. You guys are all scientists already. Look at that. Now, scientific inquiry is going to help develop understanding of the world around us. It's going to help us understand why things are the way that they are. Not all things in science have been discovered yet. There are still tons of discoveries out there that have yet to be made. So let's go ahead and let's get into it. We have a theory and we have a law. What is the difference? Okay, I want you to think about what a theory means outside of science and a law. Think about both of those, okay? A law outside of science, if you're taking, we offer like a criminal law class or something here, like a criminal something. My degree's in criminal justice, actually, and I talked about laws a lot when I was in college. A law is something that is written down and you have to follow. Otherwise, you shall face a penalty. Law and science works for specific conditions and answers the what happens. So, we have our law of gravity. When we drop things, let me find something to drop on my desk at home. If I drop this deck of cards, it falls. That's the law of gravity. It's not the theory of gravity. It's the law. Now, we have a theory. Now, a theory outside of science typically means that you have an educated guess. A theory outside of science is actually more of a hypothesis for us, okay? A hypothesis is going to be an educated guess. Theory is going to rely on inference, and it answers the how. So we have our Big Bang Theory, which if you're in earth science, we're going to talk about pretty quickly. If you're in science, we have our theory of evolution, which we'll talk about later. Now, both of them are based on evidence, and both of them are going to always undergo constant change because there is always new evidence that is available. All right? So these terms mean they have different meanings in science than they do in regular speak. So when we're talking in science class, in biology or in earth science, we need to make sure that we are talking about theory versus law. Okay? We need to make sure that we're using the correct terms with it. Don't say I have a theory about this, say I have a hypothesis or something of that sort. Okay? Let's move on. Now here's our traditional scientific method. Okay? It always begins with a question. We have to ask a question. After we ask the question, we have to learn about it. We have to understand our question. So you have to do some background research. After we've gone through the background research, we're going to construct a hypothesis which is written in an if-then statement. If we do this, then this will happen because. So we construct a hypothesis. A hypothesis is going to be an educated guess. That is important. And then we are going to test with an experiment. After we construct a hypothesis, we need to test it. It's like me working on these links for this or for e-learning. I don't know if it's going to work. If I change it to this, then this is going to happen because I'm using a different site or I'm using a different video. I have to test it, which sadly y'all are the ones that get to test it. And then if it doesn't work, I have to analyze my results and I have to draw conclusions based off of that. First period yesterday was very different from seventh period. I don't have an eighth period. Sorry. You guys do. Sorry. I don't. But I have a first period and I have a seventh period. My first period bio class was very different from my seventh period bio class. Okay. Is that bio? I'm gonna look. I'm not even gonna lie. Yeah, seventh period is bio. But they were completely different because of that. Now, if your hypothesis is true, you're going to report those results. If your hypothesis is false or partially true, you're still going to report those results. Even it's okay if your hypothesis is wrong. Tons of inventions have been created because they found ways to not make things. Thomas Edison didn't just decide that he was going to build the light bulb out of the blue, and he didn't do it right the first time. It took him time after time again of doing this, of going through this process, of figuring out how am I going to make this work, or why does this happen, and why. The scientific method is nothing more than a way for you to test something, and if it wasn't true, you can go back and guess what you can do? You can change your hypothesis and you can try again. That's the lovely part about science, is that you can keep trying until you kind of get the result that you're looking for, or you realize that maybe your hypothesis or maybe the direction that you're going with it is not 100% correct. Now, like I said, here's a hypothesis. It is a tentative meaning it's not set in stone. This is not a theory and this is not a law. This is an educated guess. I about knocked my fan over. I apologize to y'all. It is a testable explanation for something that you have seen or think will happen in a given situation. It's a testable explanation. You can perform a test on it. It answers a question. Notice how I said if, then, kind of because. If a plant is not given water, then it will die, or it will dry out and die. Now, a really good hypothesis statement is going to have a because afterwards, because you have to rationalize why you think that a plant without water is going to dry out, because we know that plants require water as one of their necessities to survive. Next question. Can we test this? Is it testable? If it is not testable, it is not a hypothesis. And can we predict and explain the potential outcome? This is the because part of this statement. Okay, if, then, because. Good or bad. When there is more oxygen in the water, rainbow trout suffer more lice. Our universe is surrounded by another larger universe with which we can have absolutely no contact. Are these things good or bad? Are these good or bad hypothesis statements? So, ladybugs are a good natural pesticide for treating aphid-infected plants. and aphid-infected plants that are exposed to ladybugs will have fewer aphids after a week than aphid-infected plants that are left untreated. So I want you to think about this. I want you to pause the video, kind of go through the ones that you think are good or otherwise helpful. Okay? So, number one, when there is less oxygen in the water, rainbow trout suffer more lice. That is a good hypothesis statement. Our universe is surrounded by another larger universe with which we can have absolutely no contact. There's really no why to that. Yeah, we really can't test it. So, not a good one. Second one, ladybugs are a good natural pesticide for treating aphid-infected plants. This is more of a statement. This is not a hypothesis. This is not testing something. This is just saying this is that. That's not a hypothesis. Aphid-infected plants that are exposed to ladybugs will have fewer aphids after a week than aphid-infected plants that are, that are left untreated. This is a great hypothesis statement down here, okay? The reason being is because it says, okay, I think this is going to happen versus this. It is testable, and it's actually telling you what you're going to test. Steps to complete an experiment. This is our method. They must be very specific. Think about how you would how you would tell someone to make a pancake that has never made one before. The directions have to be very specific. Include any measurements or amounts. And then we have variables and groups. We have our independent variables, which are the variables that get changed in an experiment, and this goes on the x-axis. Okay, we use an acronym, I'm going to move my face, called dry mix. Dependent, response, and y-axis. Manipulated, independent on the x-axis. I'll move my face back over now. So, that's our acronym for it. Independent variable is a variable that gets changed in an experiment, and it goes on the x-axis. Dependent variable is the opposite. It's the one that we measure, and it goes on the y-axis. When I say measured, typically this will be in some sort of metric unit. Grams, meters, centimeters, nanometers, all of those things. It can also be in inches, which is an imperial measurement. Either way works. Experimental group. Different amounts of treatment applied. Our control group means that they receive no treatment at all. Typically, they'll receive a placebo, which we'll go over later. And then we have constants, which are things that stay the same throughout the entire experiment. These are things that remain unchanged because when we do an experiment, we change one variable, just one variable. Now, here's some practice. Variable practice. I want you to go ahead and read these and answer them. I'm going to pause the video for a second, and then we'll come back and we'll go over them. Okay, Stallions, so you should be done with practicing this. If plants are watered, the growth height will increase. What is being changed? It's the amount of water. What are we measuring? The height. Now I'm going to kind of get through these because I only have a certain amount of time. I'm going to leave it right here for a second. Go ahead and pause it if you need to. But we got to get going. These last two, you guys can go through kind of on your own. What can you find? Okay? I want you guys to look at this, and I want you to read it. I want you to kind of understand it, but we're going to move on here in a second. I'll post a supplemental slide for this in the PowerPoint so you guys can actually go over it. Now, perfect results. They never usually exist. It's okay to get bad or unexpected results because sometimes bad results are the best results. Okay, I'm going to move my face down here so we can see this. All of these have been found by accident. Microwaves, they're found by trying to work on a radar. X-rays, once again, found in a way that was very, very, very accidental. You can click on this link right here to see about some inventions that were very accidental. The one that I think is most interesting is Velcro. It's because there was a man that was very adventurous, and he was annoyed by these burrs. So he created something that would catch onto these burrs to help remove them. And Play-Doh is meant to clean wallpaper, which is kind of cool. Okay, Stallions. So, I'll pause this. I want you to watch the video and identify as many parts of the experiment as you can, including the independent variable, what they're measuring, which is the dependent variable, and any constants, experimental group, control group, all of that. I'm out of time for the day. This is our last slide. See y'all tomorrow, Stallions.